Hello, myself T. Kaushik Reddy from CACA, and my roll number is 2295800570, and my AET Tech Talk for Cloud Application Development, that is CAD, is driving the cloud to true zero carbon. So let's get started. Let's get started with the introduction. So this is an introduction for the driving the cloud to zero carbon, to true zero carbon. Introduction: the rapid expansion of cloud computing has brought undeniable benefits from enhancing digital access to powering critical infrastructure. However, this growth also comes with a substantial environmental cost, as the demand for data storage and processing drives a large carbon footprint. Data centers alone are predicted to consume up to 8% of the world energy by 2030 without significant intervention. Recognizing this, cloud providers ecosystems, the journey involves more than just renewable energy adoption. It requires rethinking operational efficiency, implementing AI-driven energy management, and building sustainable supply chains by working towards a zero carbon future. The cloud industry not only addresses its environmental responsibility, but also sets a benchmark for innovation in sustainable practices. The importance of a zero carbon cloud: rising energy demands, environmental responsibility, corporate social responsibility, setting industry standards, global emission reduction, inspiration border transformation. Broader: rising energy demands. A cloud service grow, data centers consume increasing amounts of energy, potentially ri- rivaling the energy usage of entire countries. Reducing the common carbon emissions is critical to combating climate change, and cloud providers have the opportunity to lead by the example. Sustainable practices are increasingly valued by businesses and consumers, influencing choices in service providers, setting industry standards. A zero carbon commitment in cloud computing can set a precedent, encouraging sustainable practices across the tech industry. Global emission reduction. Reducing the emissions from the data centers can significantly decrease global carbon footprints, supporting international climate goals. Inspiring broader transformation. As an influential industry, cloud computing can inspire similar zero carbon initiatives in other sectors, amplifying its positive impact on the environment. So, how cloud computing slashes enterprise carbon footprint? First, the cloud adoption and sustainable business goals. Then, the can cloud adoption reduce carbon emissions? Tips that help enterprises reduce the carbon emissions. So, let's know. Renewable energy integration. 100% renewable energy commitment. Major cloud providers are striving to power the data centers entirely with renewable energy sources like wind, solar, and hydropower, significantly reducing independence of fossil fuels. Investment in renewable projects. Providers are not only purchasing renewable energy, but also directly investing in renewable infrastructure, often building their own solar and wind farms to secure clean energy. Location-based optimization. Data centers are strategically located in areas rich in both renewable resources to maximize access to sustainable energy, further reducing the carbon footprint. Battery storage and grid stabilization. To address renewable energy intermittency, providers are investing battery storage technologies, allowing them to store access energy and stabilize supply during peak demands. Partnership and green power purchases. Cloud providers often collaborate with energy companies to purchase green energy at scale, accelerating renewable energy production and infrastructure development in local regions. Transparency and accountability. Many providers report their renewable energy usage and carbon footprint transparently, setting benchmarks and inspiring on other industries to adapt similar sustainable practices. Sorry. So this is the smart grid. So in the smart grid, which includes wind, hydropower, windmills, which provides the wind while rotating, hydropower, solar energy, energy storage, geothermal energy, heat pump, bioenergy. On the right, we have the solar panel, then the inverter, then this switchboard and smart meter. And from the switchboard, it is consumed by the consumer. That is to consumer. Energy efficient data centers, advanced cooling systems, utilizing innovative cooling methods like liquid cooling, direct to chip cooling, and ambient air cooling helps to reduce energy consumption significantly as cooling traditionally accounts for large portion of data centers energy use. Energy efficient hardware. Leveraging energy optimized servers, storage systems, and network equipment reduces the overall draw power draw, with more efficient hardware translating to fewer emissions and lower costs. Intelligent power management. AI and machine learning are employed to optimize energy use by dynamically adjusting power requirements based on demand, which minimize waste and maximizes resource efficiency. High density server design. By adopting high density server setups, data centers can achieve more compute, more power per square foot, allowing them to process more data without needing extra physical space and power. Renewable energy powered backup. Instead of traditional fossil fuel based backup generators, data centers are beginning to use renewable energy for backup power, such as battery storage and hydrogen fuel cells. Sustainable supply chain, sustainable sourcing, eco-friendly manufacturing, efficient resources, logistics, circular economy, supply chain transparency, supplier collaboration. Sustainable sourcing, use responsible sourced and recycled materials. Eco-friendly manufacturing, select suppliers with lower emissions, energy efficient productions. Efficient logistics, optimize shipping to reduce carbon footprint. Circular economy, extend product lifespan through refurbishing and recycling programs. Supply chain transparency. Report on environmental and social practices of suppliers. Supplier collaboration. Align sustainability goals with suppliers for shared impact. So this is the process of 5 steps that is unlocking the potential of server virtualization, embrace the power of renewable energy, unleashing energy efficiency innovations, consolidation for sustainable future, responsible data lifecycle management. AI and operational efficiency, dynamic resource allocation. AI algorithms can optimize the distribution of computing resources based on real-time demand, minimizing waste and ensuring energy is used efficiently. Predictive maintenance. AI can predict hardware failures and optimize maintenance schedules, reducing downtime and energy consumptions associated with repairs and replacements. Energy consumption monitoring. AI tools can continuously monitor energy usage across data centers, identifying areas for improvement and suggesting adjustments to optimize performance. Smart cooling management. AI can analyze temperature and humidity levels, adjusting cooling systems dynamically to maintain optimal conditions while conserving energy. Workload optimization. By intelligently managing workloads, AI ensures that resources are utilized effectively, running jobs during off-peak hours when renewable energy available may be higher. So this is the artificial intelligence in the energy sector. First, the planning. And in the planning, we have three processes that are optimization, efficient multiple battery usage, and routing of EV charging points. And on the left, we have the computer vision. In that also, we have the three proactive geospatial monitoring and defect classification, then solar potential geo mapping, and on the right, we have the robotics, which includes drone-powered fault detection, solar cell production, hydraulic turbine welding. And in the machine learning, we have failure prediction, electric grid management, RL control of EV charging. Then the carbon offsetting and sequestration. Carbon offset projects. Cloud provide invest in projects such as deforestation, renewable energy, and conservation efforts to compensate for the carbon emissions. Investment in green technologies, supporting technologies, and capture carbon emissions or reduce greenhouse gas output such as carbon capture and storage CCS systems, verification and certification, partnering with the third-party organizations to ensure that offset projects and legitimate measure and contribute to real carbon reductions. Community engagement, support local local communities through initiatives that promote sustainable practices and biodiversity, enhancing the store social impact of offset projects. long-term sequestration, investing in research and development of innovation carbon sequestration methods, including soil carbon sequestration and bioenergy with carbon capture and storage, BECCS, industry collaboration and mm, policy support. Cross-industry partnership, cloud providers collaborate with technology companies, environmental organizations, and academic institutions to share best practices and develop sustainable solutions. Participation in sustainability initiatives, joining industry groups and coalitions such as the Climate Neutral Data Center Pact and RE100 to commit renewable energy and sustainability targets, advocacy for green policies, engaging with government to promote policies that incentivize the renewable energy adoption, energy efficiency, and sustainable practices across the tech industry. Development of industry standards, contributing to establishment of benchmarks and the standards of sustainability in cloud computing, ensuring a consistent approach across the industry. Investment in research and innovation, collaborating on research initiatives focused on renewable technology and energy efficiency and carbon reduced strategies. Roadmap to true zero carbon. Short-term goals are 1 to 5 years, 100% renewable energy transition all data centers to renewable energy resources, energy efficiency, upgrade to the efficient hardware and advanced cooling technologies, AI optimization, implement AI for workload management, energy optimization. Midterm goals is 5 to 10 years, carbon neutrality, offset remaining emissions to a verified carbon projects, and circular economy, establish recycling and refurbishing programs for hardware and sustainable supply chain, collaborate with suppliers for sustainable sourcing and production. Long-term goals, 10 plus years, carbon negative operations, exceed carbon neutrality by removing more carbon than emitted, carbon sequestration, innovation, invest in and develop carbon capture technologies, leadership in standards, advocate for sustainability standards and supportive policies, ongoing efforts, transparency, regular reports, progress towards sustainability goals, continuous improvement, adapt strategies based on new technologies and stakeholder feedback. There is a green cloud computing roadmap, that is assess your current data setup and understand its energy consumption is the first part, and the second is embrace the power of virtualization and consolidation is the second, and the third is optimizing your resource allocation, and the fourth is data storage optimization, and the five is monitoring and analytics. So the conclusion is, in conclusion, achieving a zero carbon cloud is essential for sustainable future, as the environmental impact of expanding cloud computing must be addressed proactively by integrating renewable energy sources and enhancing energy efficiency, developing sustainability supply chain, leveraging AI for operational optimization, and implementing effective carbon offsetting and sequestration strategies. Cloud providers can significantly reduce their carbon footprint. Collaboration with the industry and advocacy for supportive policies will further accelerate this transition. Following a structured roadmap with clear goals allowed stakeholders to work together toward carbon neutrality and leads the way in creating a truly sustainable cloud ecosystems that positively impacts the planet for generation to come. So yeah, thank you. This my topic for CAD, that is cloud application development, and this is the end of my Tech Talk for cloud application development.